So next we will see helium neon laser. This is also historically an important laser because it is the first gas laser which was operated successfully, and this was done by Ali Jawan, the person on the right side. He is Ali Jawan, and actually these two people were involved in the development of this laser. And this one is on the left side, it is William Bennett, but Ali Jaman contributed more. So if somebody asks you who discovered who invented helium neon laser, it is Ali Jaman. So anyway, this was also developed in the year 1960. You can see all the once the ruby laser was demonstrated, then we have got a series of lasers. Several research groups did their work on developing newer and newer lasers by changing the active medium. So immediately after the ruby, you have got the helium neon laser. It is actually both are in the same year 1960. So okay, this is helium neon laser. So when we come to the construction part, I have used a sketch here on top of this slide. You can see there is a battery, and through a resistor and capacitor arrangement, it is connected to two electrodes in a tube, and that is a glass tube. So whenever we are going gas lasers, you will have to take the gas inside the glass tube. So we call that glass tube as the plasma tube because during the pumping process, a lot of ionization will be taking place. So it will be like a huge collection of plasma inside the tube. So it is referred to as plasma tube. In the construction part of helium neon laser, a mixture of helium and neon is the active medium. A mixture of helium and neon is the active medium. It will be taken inside a plasma tube or a glass tube. And the ratio in which they are mixed is, since they are gases, you will have to mention the ratio in terms of partial pressure. So, in terms of pressure, the ratio is again 10%. Neon is very little, 10 percentage by pressure, and helium will be more. So that is the active medium. And the active center, previously we know in the case of ruby it is the chromium ions which are the active centers. So here it is the neon atoms which are the active centers. And what is the role of aluminum oxide in the previous case? Like that, helium also has got a role here, but helium is playing a more important role in the case of helium neon laser. Helium will help in the process of population inversion or creation of population inversion. So helium will uh, facilitate the pumping transition. So that is the role of helium. So it is a more important role than just acting as a host medium. So that is the construction, or that is the active medium part. And the second one is you'll have to explain what type of pumping we are using. So here you can see it is connected. You have got two electrodes which are placed inside the plasma tube. So those electrons are in contact with the gas molecules, helium and neon, and it is connected to the battery. So when we turn on the battery by the the gas molecules are subjected to this electric field. So they will be getting ionized. So that means the outermost electrons will be removed from these atoms. So they will be ionized. So in the ionization state, even otherwise, since they are gas molecules, they will be moving randomly. But when they are in the ionized state, their movement, they will be accelerated. Their movement will be very faster. So they will collide with other atoms, and again more and more ionization will take place. So ultimately we'll be having a mixture of free electrons and ions. So or that is actually the plasma, and that's why we call it a plasma tube. Or in when we have this kind of a system, when we subject these active molecules into an electric field, they will be ionized and electrical discharge will be taking place. So the plasma will be generated, so the energy will be, taken from the electric field, and it will get ionized, and the ionized atoms will be moving faster, and they will collide, and they transfer their energy to the atoms with which they are colliding. So this is the way in which the transfer of energy is taking place, or the excitation is taking place. So the pumping in this case is by making use of electrical energy. So it is referred to as electrical pumping. So this is not optical pumping, it is electrical pumping, or pumping through electrical discharge. Then the third part in the construction process is the optical resonator. Obviously, since it is gas molecules, you cannot go and polish them. So we will have to use external mirrors. Extra mirrors should be used, and that is what is shown here. You have got a pair of mirrors uh, which are placed at the end of this uh, plasma tube. There are two mirrors which are shown to be at an angle, uh, and that is fixed to the plasma tube. And if those mirrors are, for example, one of these mirrors should be 100% reflecting. In this case, it is the right mirror which is expected to be 100% reflecting. But this mirror is transmitting, so we have that transmitted portion again falling on another mirror. So it is actually, a combination of mirrors. But anyway, this, for example, this planar concave mirror is kept there. So all these, actually these four mirrors will together work as the optical resonator. So that is the construction part of helium neon laser. Helium neon will also be emitting red color light. In the case of ruby, the output wavelength is 694.3 nanometer, which is towards the infrared side of the red region. It is red in color, but near the infrared band. Whereas in this case, it is closer, or it is towards the lower wavelength side. It is, but still it is red in color. Actually, 600 nanometer onwards to almost 700 nanometer, you can call that to be red emission. So here it is 632.8 nanometer. So in this diagram, I have shown some of the photographs of this helium neon laser. Most often the helium neon lasers are very small and compact and low power lasers. It is very easy to operate and very easy to handle, very easy to transport. Just have to turn on a switch in order to get the output. Immediately when you turn on the switch, the output will come from the output port. So two examples are shown here. You can see these type of lasers in almost all research labs. So the first one on the left side, it is a very low power laser. The power output is in the range, maximum is 2 milliwatt. It is red emission. Typically the emission is red in color, 632.8 nanometer, but interestingly, helium neon laser is capable of giving green color output also. So there is a green Hini that is shown on the right side. But anyway, the maximum power that we can expect, the helium neon laser is not designed to be a high power laser, but if you can, like for example, expect 20 milliwatt or 25 milliwatt, that will be the maximum that you can get from helium neon laser. And moreover, if it is operating in the green region, it is having more power capability. But nowadays, whenever you see a helium neon laser, it will be red in color. So that is the most common wavelength in which it is made to operate. Nowadays, these green Hini, it's very difficult to see them in labs. So coming to the construction, coming to the working part, you will have to consider all the energy levels. So in this case, now we are drawing the energy levels of both helium and neon, because helium is helping in the pumping process, so they so its energy levels should also be made use of. Just like we have used two energy bands above the upper laser level of chromium, here we are using extra energy levels from helium in order to have a better population inversion. So these are the energy levels. You can see E1 is shown to be the ground state. Both helium and neon is at the same level in the ground state. Then you have got an energy level E2, and in the case of neon, E2 is shown. That is the level above E1. Then we have got E3. So E3 is shown to be green in color. It is drawn to be green using green color, and you can see the level E3 in case of helium and the level E3 in the case of neon, both are almost at the same value. Then we have got an energy level E4, which is drawn only in the case of neon. Then above that we have got energy level E5, and in this case also E5 in helium and E5 in neon, both are almost the same level. Actually, in this diagram, E3 on both sides are shown to be equal, E5 on both sides are shown to be equal, but actually it is not the case. The neon energy level, or E3, or the energy level corresponding to E3, will be slightly lower than lower in the case of neon than the corresponding E3 of helium. Okay, similarly, E5 of neon will be slightly below E5 of helium, but here it is not considered. It is shown to be of the same energy. So during the electrical discharge, what is happening is that helium atoms, they are very lightweight. It is actually, when you compare helium and neon, helium is lighter in weight. So the helium will absorb, helium atoms which are present in the ground state will absorb energy from the electrical discharge, and it will go to two possible excited states, E3 and E5, and that is shown to be the transition using the black vertical upward arrow, okay, in the case of helium. So that is the first transition which is taking place from E1 to E3 and E5. That is by absorbing energy from the electrical field. Then what is happening is that there are two energy levels in the case of neon which are very close to E3 and E5. So what is happening is that the helium atoms which have gone to the levels E3 and E5, now they are in the excited state, so they will be highly unstable and they will move vigorously through the glass tube. And since in the plasma you have got a mixture of helium and neon, they will be moving through, when they are moving through the glass tube, they will encounter other neon atoms and other helium atoms, and in this case what is going to happen is that a helium atom which is in the level E3, it will move through the plasma tube and it will hit the neon atoms in the ground state and will transfer its energy to the neon atom in the ground state. So now the neon atoms will go to its E3 level. Similarly, the helium atoms which are in E5 will collide with neon atoms in the ground state and will transfer its energy, so that now the neon atoms can go from its ground state E1 to its upper state E5. So essentially what has happened here is the atoms of the neon are now transferred from the ground state E1 of neon to its two excited states E3 and E5, and for this transition we have used the help of helium atoms. So you can see in between helium and neon energy levels, two black horizontal arrows are shown. So those arrows will indicate the transition of transfer of energy from the excited states of helium to the ground state of neon. So that is through collision. The excited state of helium atom is colliding with the ground state atoms of neon, and in that process or through that collision, the ground state neon is transferred to the excited states of neon. So that is how we create population inversion. So those two green energy levels, E3 and E5 of neon, are referred to as the upper laser level. Okay, so this is how the population inversion is taking place. So actually, I told you earlier, most common wavelength in which the helium neon will be operating is 632.8 nanometer. Here it is written to be micron, you just correct it as nanometer. It is 632.8 nanometer. It is the most common wavelength. So if that is the wavelength in which the helium is neon laser is operating, then the upper laser level is E5 and the lower laser level is E2. So in this case, I will just explain this using this 632.8 nanometer emission. So in that case, our upper laser level is E5 of neon and the lower laser level is E2 of neon. Okay, so now we have created, actually what we have done is through the help of helium, we have transferred the neons from its ground state to E5. For the moment, you just forget this E3 in neon. So we have got population inversion between E5 and E2. Then what should happen next? So since this level E5 is unstable, it will, one of the atom in E5 will undergo spontaneous emission, and it will emit a photon of wavelength 632.8 nanometer, and that photon will move through the plasma tube and it will hit another neon atom in the level E5 and stimulate that atom to de-excite. So the photon number will become 2, and those two photons will again stimulate two more atoms in E5 of neon. So the photon number will become 4. Like that, there will be an avalanche of photons. So that is what is happening. So all those photons will travel to one side. I will be getting reflected from that mirror. It will go back to the active medium, and again the stimulated emission process will continue, and we'll be having an output. I mean, that process of multiple reflections from this optical resonator will take place, and we will be having a huge number of photons inside, and it will result in emission. So this electrical discharge, when you turn on the source, pumping source, it is continuously providing electrical discharge. It is not giving like flashes. So we have a continuous outputs coming from this helium neon laser also. And in this case, spiking is not important. We don't spiking is a phenomenon which is observed in the case of solid state lasers. So this is a laser whose operation is in continuous manner. When you turn it on, once when it begins to give light output, we will continuously get the output until you turn it off. So that type of operation is referred to as continuous wave operation, or CW, continuous wave operation. Whereas in the case of Ruby, it is pulsed operation. You have got pulses. That means you have got high intensity, and then we don't have any intensity. And even when output is coming as pulses, and even within a single pulse you have got variation in intensity like spikes. So that doesn't happen in the case of helium neon laser. Why the spiking is not present here is a peculiarity of the energy levels. First of all, the pumping source is present continuously throughout, and the energy levels are relatively sharp, so spiking is not obvious, and the output, we keep on getting the output continuously. So that is the operation. So we have explained it in terms of these 632.8 microns. Here the green emission is not shown. Actually, there are more energy levels here which we'll have to use, and these two, E3 and E5, are the easiest level in which we can create population inversion, and that's why helium neon it is easy to make a helium neon laser operate at 632.8 nanometer, whereas if you want to operate it at green color, then you'll have to make use of some energy levels in between, which is not shown here. So other possible emissions are this 3.391 microns, which is a longer wavelength, and then 1.152 micron, which is again longer compared to the 632.8 nanometer. If those are the emissions, at a time it can be made to operate only at a single wavelength. So if it is made to operate at 3.391 microns, then the upper laser level is E5 and lower laser level is E4. Whereas if it is operating at 1.152 microns, then the upper level will be E3 and the lower level will be E2. So this is the operation, but again you just focus on the 632.8 nanometer. That is the most important emission, and that will be sufficient. But you just keep in mind that it is possible to make this laser operate at different wavelengths. But whatever it be, when the operation is at 632.8 microns, you can see after the laser emission, the atoms are coming down to the level E2. E2 is our lower laser level. So E2 is actually an excited state. So during the laser operation, you have the atoms in the level E2. Once when you get the output, the atoms have come down to the level E2. But E2 is also an excited state, so the atoms cannot stay there. They will again make one more de-excitation, and it will come down to the level E1. So in order to do that, in that process also, it is not necessary that it will give out any photons. Most often this transition from E2 to E1 will be through collision at the walls of the plasma tube. Sometimes some spontaneous emission can also be the reason for the de-excitation, but most often the de-excitation reason for that de-excitation is collision of the gas molecules with the walls of the plasma tube. Now all the atoms have come down to the ground state, but the discharge is still there, electric field is still there, so all the atoms will again go to the upper laser level and the process will continue. So since the source of pumping is available continuously, we will be getting continuous output also. So this is the working of helium neon laser. So you go whenever you want to try to explain, you explain all these things and explain the energy levels, energy level diagrams also. So to sum up, we have seen the construction and working of a ruby laser and helium neon laser. And to coming up in the session 5, we will mainly see the applications of lasers, but before that we will compare these two lasers again in terms of the number of energy levels we use to create population inversion. So like for example, how many energy levels you require in order to create population inversion and in order to have the laser action. For example, if there are two energy levels, only two energy levels are required, then it is referred to as a two-level pumping scheme. If three levels are used, it is referred to as a three-level pumping scheme. And if four levels are used, it is four-level pumping scheme. So we will, before we go into the details of the applications of lasers, we will see the pumping scheme, the classification of pumping scheme. So you revise this topic. Then I actually posed a question, which was it, like what is the reason for spiking? I think I explained. Well, if there are any questions, you can post those questions in the comment section, and we will discuss them in the forum. Okay.